Hi, this is Dave Shun with Fireye. In the next 10 slides, we're going to look at the sequence of operation for the MicroM control using an MEP230 programmer module. The website is listed here as well as the bulletin number if you need further information. This first slide shows the basic wiring of the MicroM control using our MEP230 programmer module. In the upper right hand corner you will see the smart LED lights and their functions. If we come off of L1, you'll see that it goes through the operating control and connects to terminal 7. The airflow switch is connected between terminals 7 and 6. Terminal 8 operates the blower motor. 2 is your L2, A your alarm contact. On the right hand side you see S1 and S2 connected to the flame scanner. Terminal 3 is your gas pilot valve, 5 your main fuel valve, and 4 your ignition transformer. Terminal 1 is wired to L1 and should always be hot to record off-cycle faults. On a call for heat, the operating control closes and terminal 7 is energized. Internally, relay KB closes and powers up the blower motor through terminal 8. Internal relay KB pulls in and the blower motor is energized through terminal 8. Once the blower motor starts, the airflow switch has 10 seconds to make through terminals 7 and 6. Once it does make, the airflow switch LED comes on and purge begins. At this point, the control will initiate pre-purge and do an internal. Once purge is complete, we will initiate pilot trial for ignition. This will energize terminals 3 and 4, and the PTFI light will come on. The length of PTFI is either 5 or 10 seconds, and that is selected by the dip switches on the control. Flame must be detected within the PTFI period. In this case, light off was successful and the flame light is on. When flame is detected, you'll notice that KF2, which was normally closed, now opens, and KF1, which was normally open, now closes. This drops off the ignition transformer and opens up the main fuel valve. Pilot trial for ignition is now complete and the PTFI light goes out, while the flame, airflow, and operating control lights remain on. We are now in the run mode. Terminal 7 is energized through the operating control. Terminal 7 to 6 is energized through the airflow switch. Terminal 8 energizes the blower motor. Terminal 3 energizes the pilot valve. Terminal 5 energizes the main fuel valve. And as always, Terminal 1 is energized. We are now in the run mode. You can see there is power to terminal 7 and from 7 through the airflow switch to terminal 6. There is also power on the gas pilot valve terminal 3 and the main fuel valve terminal 5. Meanwhile, a flame signal is coming back to terminals S1 and S2, and as always, L1 to 1. When the call for heat is satisfied, the operating control opens and power is removed from terminal 7, which also removes power from terminal 6, and 3, 5, and 4 no longer have energy. Terminal 1 remains powered, so the control can record off-cycle losses. If post-purge has been selected, we will internally hold relay KB closed to run the blower motor for a pre-selected time, 15 seconds.